Welcome back to Let's Code. Today we're talking about the Bevy 0.9 upgrade for the Block Breaker game that we've been working on this channel. Now, the most major changes are in the UI library that we're using called Kayak, which is responsible for the 9 slice images that represent the container here, as well as the buttons themselves. And then, of course, also the hover states on the buttons and the text inside of them. If we hit new game, we can see that the game does indeed play. Bevy Hanabi is updated. We can see particles. Bevy Rapier is updated. We can see the collisions and so on and so forth. So let's start off in the cargo toml and take a look at the versions and the crates that we're using in this project. You can see that we have Bevy 0.9 right at the top. Bevy Asset Loader has been updated at 0.14. Bevy Prototype Leon has been updated, as well as IES Loopless and Bevy Rapier 2D, which is now at 0.19. Kayak UI got its first crates.io release, so we upgraded from an arbitrary git commit hash to the Kayak UI 0.1 release. And Kayak UI is where the vast majority of the changes that we'll be going over happen. One minor note about Bevy Hanabi is that while 0.5 is out and is compatible with Bevy 0.9, I did run into a bug that is already fixed on the main branch. It has just not yet been released to crates.io. So that's why we're depending on the git hash here instead of on crates.io. But I assume that in 0.5.1 or whatever the next release is, that this issue is fixed. So before getting to Kayak UI, let's get into the main.rs file. You'll notice that all of the spawn bundle commands that we used to have before are now spawn, since spawn is now the preferred way to insert a new entity with a set of components. The API for Bevy Prototype Leon didn't really change, although Bevy 0.8 and 9 introduced new materials that we could use. So I think that I'm going to actually take Bevy Prototype Leon out in a future video and rely on a material 2D for the circle. So I've left that piece alone for now, since I'm intending to make that change in the future. And you can see that the inserts that we have here are still totally okay. This is still a valid way of using the API. You can spawn and then insert as many components as you want to. The other way to do it is to use spawn with a tuple. So you see the tuple start here. We've got the sprite bundle and then all of the other components as elements in this tuple. And this is what I've done for most of the other spawn commands. I've turned it all into a single tuple, and then I've collected all of the components into that tuple. One other note that I'll make is that we used to have manual insertions of the transform and global transform components, but instead we're now using spatial bundle. Spatial bundle is something that includes basically everything that you need to insert to make sure that something can be seen on the screen. So that makes it a good replacement for the manual insertion of the transform and global transform components, because it also includes the default values for visibility and computed visibility. And of course, because resource is now an explicit derive, we had to derive resource for any resources that we're inserting as, well, resources. And that covers really all of the logic that needed to be updated other than the UI logic for Bevy 0.9 for the Block Breaker game, which is pretty awesome because we've got a bunch of assets here. Bevy Asset Loader, of course, updated, but the APIs don't seem to have changed in the way that we're using them. All of the logic for anything custom that we wrote is totally fine and works. All of our custom commands have only had those spawn changes, so minor superficial syntax changes. Nothing changed the actual behavior of our custom spawn commands. And that's it. Pretty much everything else just worked. But that does bring us to the massive changes that we had to make here. And that's the changes in Kayak UI. Oh, look, there I am right there. So Kayak UI is a declarative UI library or crate for Bevy. So we aren't using the default Bevy UI. So when the Bevy UI changes happened in 0.9, we weren't really affected by them. However, because Kayak UI is such an early project and the commit that we were on is almost a proof of concept more than a production ready library, according to the maintainer, we of course are going to have to update with the breaking changes that are almost certainly coming. And that is actually noted right here. Kayak UI is in the very early stages of development. Important features are missing and some documentation is missing. Kayak UI is designed to only work with Bevy. But very importantly, if you're working with Kayak UI, you do actually have to go read the Kayak UI book or you will be very confused. After going to read the book, I would also suggest going through the examples and making sure that you understand each of the examples. The TLDR of Kayak UI is you get to use the RSX macro and you get to write something that looks like JSX and you get UI out of that. So it's a Bevy plugin. You drop in the Bevy plugin. It comes with some widgets that do some nice things for you, like we'll see in a second. And that's it. You just write it sort of like you would write HTML, and you have to get your data in a very specific way, but that's about it. So on to the changes. We have a new plugin here. So we have the Kayak context plugin and Kayak widgets. You can now optionally include all of the Kayak widgets. So things like images and 9-slice images and whatever else they have in there. Choosing a font and using it, as well as spawning the UI camera bundle, have stayed the same. So in this case, Kayak UI chooses to use signed distance fields, or actually multiple signed distance fields in a file. See if I can, which looks like this, which is absolutely wild. But basically this is like, if you've been following the shader work that we've been doing with Bevy, you can think of this as a texture, and then signed distance fields use each of the values, or rather the implementation that they're using here, MSDF, uses multiple signed distance fields, and they use the channel of the colors to represent each of the signed distance fields. So you've got an RGBA, and you can see that here. I don't think I can zoom in to a size that will be reasonable, but if you look around here, you can definitely start to make out some of the letters. And that's an MSDF file is all that is. It's a texture image that represents signed distance fields that represent fonts. But that didn't change, so that all works the same. So this game UI function is our setup function. So the way that Kayak works is you set up some systems and some widgets. The startup system and those other systems all run once, basically. So this startup system will run once. It will bootstrap our Kayak UI sort of context and widget tree and things like that. And then Kayak takes over from then and handles passing in new props and running update functions and things like that. So it's not quite a direct integration, because while you can do things like make queries or access resources in, say, this startup function, which is just a startup function, or in this widget render function down here, if you make a query for resources that aren't registered with the system in your widget, you will only get that value the very first time. So even if you update it, that value won't update. So you have to make sure that what you're doing is registering any values that you care about as props. So for example, here I have game menu props, where I put the game state in to make sure that we remove the menu whenever you hit new game. But let's go back to the setup function. So we set up a widget context and we set up the parent ID. In this case, this is the root, so our parent ID is none. And this RSX actually expands to a bunch of regular just Bevy ECS commands. So you don't have to use the RSX macro if you don't want to. You can sort of register and use all of the widgets on your own however you want to, using just regular commands.add or commands.insert and things like that. So we take the context and we set up all of our components. So in this case, we're setting up the game menu component, or widget, I guess we're calling them, as well as the block breaker menu button widget. One downside to the current implementation is that you kind of have to set up these components inside of the context, inside of the setup function, as far as I can tell. It's not too much of a big deal, but I could see this being quite verbose in the setup function. And also, I would rather have these being registered with the component themselves in the same file. It's a small nitpick. So we have these two functions, add widget data and add widget system. Add widget data defines the props and the state. So if you're familiar with something like React or some other reactive system, you're probably used to your components getting a set of props that you don't change as the component, and a set of state that you're allowed to change from inside the component. So this is just binding that data. And then we need to add the render function. So we'll cover this now, actually. So there's game menu render here. And that's the function that handles all of the styles and all of the rendering and all of the RSX and all of the click handlers and things like that. The way we get that to happen is we define a struct called game menu or game menu props or whatever we want. This is going to be our props, basically. Anything that gets passed to the component as data. We have to have an implementation of default for this component props. And then we have to implement widget. Now, right now, widget doesn't really do anything, but we still have to implement it. And in the future, it'll be used in more context. So once we have our props, the default values, and the widget implementation, it's advised that we set up a bundle. So in Bevy, this is super easy. We can derive bundle for some struct, and then put a bunch of components on that struct. And these components will get attached to the entity when we spawn in this bundle. So we've got our props here for game menu props, which is a component. We've got kstyle, which is allowing our component effectively to accept styles. The other important one is onEvent. Widget name is also required by Kayak UI, but right now I've just been passing that around and I haven't really done much with it. And then we can implement a default value for that bundle so that it makes it easier for us to actually use. And back in our setup function, that's how we get this game menu bundle right here. So we've got the Kayak provided Kayak app bundle at the root, and then our game menu bundle handling the menu rendering inside of it. So we've implemented widget, we've set up our props, and we've set up a function to render out what should be here. So Kayak UI actually integrates pretty deeply with Bevy and Bevy's systems. So to accept some of the arguments to a system, we use the Bevy in struct. This allows us to construct systems that require input when they're being run, or are required, or rather require a system to pass that system input when they're run. There is an example here, although if you're not used to dealing with Bevy in testing situations or environments or isolated environments, this will be a little bit hard to read. The TLDR is that if we define this square function as having an input that is a usize and returning the square of that input, then we can use whatever number that's passed in as this input. So if we run this system and something is using .run and it gives us a number, then we also get to query everything from the world because the world is being passed in here. But something gets to add these input parameters for us as well, something like Kayak UI maybe. And then this is just testing to make sure that it does in fact run and square the values. So with that in mind, what we're doing here in the game menu render function is we're defining these input parameters, which are something that Kayak UI passes to us. So we get a widget context and the entity. So all widgets in Kayak UI are now entities themselves. And we define our input parameter as a tuple that takes the Kayak widget context and the entity, or an entity. And of course, we do get to do anything that we want to set up this widget component with any of the queries or resources or any system parameters that you're used to using. So in this case, we've got commands, just like usual. We've got images, which is the Bevy asset loader set of images that have been loaded. And we've got, of course, the game menu props, as well as some state we're manipulating. So I take this opportunity in our game menu to grab the props directly using the entity. So this query has a get function on it that will take an entity ID and give us back that component. So this could also fail. It returns a result. But in our case, in this case, I don't think it will ever fail, so I'm just unwrapping. So that gives us a game menu props type for this props value. We need this parent ID for the RSX macro later. This parent ID just needs to be a value in scope. In this case, the parent is defined as the entity, so we do some entity. Then we do a bunch of styles. If you're familiar with CSS, this will look vaguely familiar. It's basically style props and choosing units or other values. And I do this for a number of different elements that we'll look at later. Suffice it to say, this is basically CSS. We've got what effectively looks like a hook for like a use state or create state signal or something like that. So we can use the widget context that we get from the input parameter for the system to define some state. We pass in the commands, the entity the state is going to be related to, and then the default value that we want to set that state to start with. And that gives us state entity, which is just an entity ID. We can then, of course, take this state query that we defined earlier and run get on it because it's a query. Queries have the get function with that state entity ID. And if it succeeds, then we have the current menu state. And if not, then we just set it to main. I chose to do a default value here instead of panicking, but you could also panic if it wasn't set. Event handlers are defined in a very similar way to the way that the system is defined. So we get on event new, and we have a closure that moves any captured variables in and uses that in struct that we talked about earlier to define the inputs that are going to be passed in by Kayak UI. We also get the opportunity to do the same thing we had earlier and define any resources that we need. In this case, this is going to be a click handler for the new game button. So I've defined that we need commands because whenever this event is click, whenever we've clicked the new game button, then I'm going to insert a resource for IES loopless to transition us into the playing state for the game. So when we click new game, IES loopless will transition us into the playing state. Our component here or our widget will know that. It will unrender the UI on top of the game, and the game systems will start up and we'll start playing. And then the return value here is an event dispatcher context and the event, and these just come from the in parameter here. We do the same thing for clicking the other buttons. So an on event, some parameters that Kayak UI is going to pass to us that are defined here. We can grab anything we need. In this case, we grab the event writer for app exit. So there's an exit button. And the way that we would exit a Bevy app is by sending the app exit event to that exit writer. And that brings us all the way down to the RSX. So RSX is a lot like JSX, and Kayak UI has moved to using bundles as the names for a lot of the components. So in this case, an element bundle is a lot like a div. So I've got this outer div with some styles, another div with some styles. This is actually one outer div and 3 inner divs. So I've got padding on the left here and padding on the right, and then the menu in the middle to center it. I actually don't know if that's still necessary, but it's the way that I had it working in the Bevy 0.8 version of the game. So I can go back and I can check and see if this is still necessary. We've also gotten rid of the if component. So there is no component like this, like if. Instead, we have something that looks a lot more like what you would write inside of JSX inside of JavaScript or somewhere else. We can use regular Rust paradigms to compare, say, the game state from the props with some value. So if the game state is in the menu state and the menu state is in the main menu, then we should show this. And we use this special constructor macro. We're just going to skip over that. But if you're doing an if statement like this, you do have to use the constructor macro. And then we get to put a 9-patch bundle inside of that with some custom buttons. The 9-patch bundle is really nice because it effectively takes something that looks like this and defines a 3x3 grid on this square, and you define where the edges should be. So if I want to define it at like 10 pixels, maybe I have a really small square, like right just surrounding the corner. And then what happens is that when this element needs to stretch in different ways, the pieces that stretch are the straight sides and not the corners. So you get these nice crisp corners, and the rest of the image scales in a way that is visually or aesthetically pleasing. So we define our image here, which is just a handle to an image in the asset database, and then how big the edge squares should be. These custom buttons are another widget that comes from a different file, which we can jump into really quickly. It's less complicated than this one, but we can pass in some of the block breaker menu button props, such as the text here for new game, or a click handler for on event. And that allows us to define our own widgets that can be reused 3 different times for each of the buttons. And at the end, we have to return a Boolean. In this case, I'm just returning true because it's the easiest thing to do right now. So if you followed that, then this is the same thing. This is a button, and this button has some state, but it's the same thing. So we've got some props, which are the text that we saw used earlier. So if we take a look at the button usage, there's this block breaker menu button text here. We implement widget for those props. We derive bundle, and we define what our interface is going to look like. So this is bundle. So this is button, on event, and the widget name. The widget name is required. The button and the on event are things that we want, which allows us to pass in button as a prop here to the block breaker menu button bundle, as well as the on event click handler. We implement default for those props, and we implement our render function. Our render function uses this in struct again. So Kayak UI will pass us the widget context in the entity, and we can query for whatever we want here. In this case, we're using some built-in struct from Kayak called button state, which contains a hovering field. So we do again the use state, the thing that looks a little bit like a hook, that gives us an ID. We can grab the text by querying for the block breaker menu button props and then getting the entity for those props. That of course can fail, so we're just unwrapping and then getting the text and then cloning the string. We've got another on event handler here, does the same thing. It's a closure that moves in the variables. This in struct defines the variables that we're getting passed in from Kayak UI, and then we can query for whatever we want as well. In this case, I'm querying for button state, which will contain whether we're hovering over or not. And in this case, we're using an iflet to make sure that if we get this state entity button from the query, then we actually can do something with it. So if their event is mouse in, then we set hovering to true. And if it's mouse out, then we set hovering to false. The only other really interesting thing about this component itself is that we take the images from the Bevy asset loader and we switch based on whether we're hovering or not. But these are both handles, so it's actually not that complicated. We just clone either one of the handles depending on which one we want to show, and thus the 9 patch image will show that image. And that's it. That's the Kayak UI changes. The Kayak UI changes are pretty deep. They're pretty large to get your head around if you haven't, even if you have worked with the old Kayak UI stuff. I would still encourage that you take a dive into the Kayak UI book and then you go through the examples if you plan on using it. And also just be aware that the Kayak UI crate will get updates in the future. So be prepared to have to update if they make breaking changes, because that is very likely for a crate that is this early in its life cycle. That said, we now have Bevy 0.9 in our block breaker game. So you can see the hover effects if I don't click on the exit button. So you can see the hover effects as we hover over the buttons, which are handling the state. You can see the 9 slice image for the outer window, as well as the 9 slice image for each of these buttons. You can see that I messed up the padding and the text is too high on the buttons, which is fine. And when I click new game, the game state is translated into the Kayak UI state and the menu goes away. And we can play the game with our 2D kinematic character controller from the last video and our vertical capsules, which is a bug. So I hope you enjoyed the video. I feel like this is going to be a pretty long one, but I hope you have a great day, and I'll see you in the next one.